Hey class, this video goes with 12.2b. It does assume that you've already learned how to calculate the standard deviation using the calculator. So if you haven't done that yet, you need to go back to 12.2a and make sure that you know how to use the calculator. Here's a little recap on that. You put the data points in your list when you go to Stat Edit, and then you choose the one variable statistics, and then the mean is the x bar and the standard deviation is the sigma of x. So here are just some examples using the average and the mean and the standard deviation. So remember that the standard deviation, when the closer it is to 0, the more consistent the data is. So I went ahead and I put this data points. The Maui News gave us the following cost in dollars per day for a random sample of condominiums located throughout the island of Maui. So I put these in my calculator under stat, and I ran the one variable statistics, and I got the average, the mu, or the x bar, to equal 136.15. And then I got the standard deviation of x to equal 130.18. So the standard deviation is 130, which is very far from 0. So this tells me that the cost of these condominiums are widely spread. The costs are widely spread out because the closer it is to 0, the more consistent it is. Closer to 0, more consistent the data is. In fact, I could say that 70% of the data is plus or minus 130.18 around or above and below the average. Below the average price of 136.15. So basically the price of these condominiums in Maui range from an average of 136, but could be all the way down to, the $50 here, $45, and then they can go all the way up if you added 136 to this to 260 or 235. And then you do have those really high points at 500 and 350. And so the costs are very widely spread out, and that's what our standard deviation basically tells us. Okay, in example 2, the Trading Post in Grand Mesa sells spinners. It's a type of fishing lure. However, the store has a very limited selection. Here are the prices. So I went ahead and put this in my calculator, and I would encourage you to do the same to practice it. And I got the X bar to be 2.14, so my average cost was $2.14. And then I got my standard deviation equaled 0.22. So that was my sigma of X. So this tells me that the prices of the lures are consistent. This is 0.22 is very close to 0. So the prices of the lures are consistent. They're all close to the average cost of $2.14, which makes sense when you look at our data. They're all about 20 to 30 cents difference, and that's what our standard deviation tells us as well. The last one is on the U.S. Weather Bureau has provided the following information: the total annual number of reported tornadoes in the United States from 1956 to 1975. So we put this data in our calculator, and I ran the one variable statistics, and I found that the average number of tornadoes for those years was 730, and the standard deviation was 167.82. I also calculated the mean, or the median. The median for this data was 678. I'll come back to that in a second. But since the standard deviation is a larger number, that means that the number of tornadoes was not consistent. And so if you look at the average, 730, you can see that we have sometimes there's 500 all the way up to 1,000. And so the data really isn't consistent around the average. The data points range from about 167 plus or minus either way, 70% of the data. And then all 90% of the data is going to be within 3 standard deviations away as well. So we'll talk about that more. But basically that this tells us that the number of tornadoes is not consistent. It's very spread out per year. The number of tornadoes changes yearly. It's very inconsistent data spread out. And we can say that approximately 70% are plus or minus 167.8 away from 730 average. So plus or minus 167 below and above, that's what 70% of those tornadoes happen between 730 minus 167 and 730 plus 167. So between 890 and 670 would be 70% of the tornadoes in that set of data. So it kind of gives you an idea. Now, when the standard deviation is very high, the median number might be something that you look for instead. So 678 might be a better descriptor if they wanted to go with, between these years, we had approximately this amount of tornadoes on average. Since the average itself has such a large standard deviation, it's not a great data point. So maybe we'd use the median to describe that instead, because that gives you the middle number. It tells us a little bit more about the difference between the high and the low. Okay, thanks for watching.